So, first let us see into the construction of a galvanic cell. When it comes to construction of a galvanic cell, it consists of two half cells. It consists of two half cells. One half cell is oxidation half cell, where oxidation takes place. Oxidation takes place, oxidation of chemical species. And so, this oxidation half cell is other way what we call it as anode. At anode it is always the oxidation. And the second one is obviously it will be a reduction half cell, where reduction takes place. So, this acts as cathode. A combination of anode and cathode is of course makes a galvanic cell. At cathode, suppose if we have at anode, if we have a metal and non-metal combination, that if we take, or if we have two metals in which one undergoes oxidation and one undergoes reduction, more electropositive metal obviously will be the one that undergoes oxidation and will act as a reducing agent. Less electropositive metal will undergo what you call reduction and will be like an oxidizing agent. Suppose if we have a combination of zinc and copper, two metals if you take, zinc is more electropositive than copper. So, in this zinc, solid zinc undergoes oxidation to Zn2 plus in aqueous solution, and because of the two electrons involved in the reaction, this Cu2 plus An at anode, this is the reaction at anode and this is the reaction at cathode. Cu2 plus undergoes reduction to Cu solid. So, here it is the electrons that transfer from one electrode to the other electrode. The flow of this electron is responsible for the electric current to in a EMF to generate in the galvanic cell. So, here at one of the half cell it is oxidation, at the other half cell it is the reduction. At the so, each of the half cell how to make and how to connect the two half cells and what exactly the things involved in this galvanic cell and how it looks like and what more involved in the construction and working of this galvanic cell. Let us see. So, here when it comes to the construction, each half cell is made by having a vessel in which electrolyte is filled in both the half cells. The electrolyte solution is the one which is having an ion common with that of electrode. Suppose like in the previous example that what we consider zinc and copper, this is a zinc rod if you consider, and this if you consider it as a copper rod, then this is a solution of Zn2 plus, that is zinc sulphate. This is a solution of copper sulphate, that is a solution of cupric ion. The electrode and the electrolyte should have the components of the same metal or non-metal. Then this is the zinc rod in the zinc sulphate, this is represented as zinc sulphate ZnSO4. So, here it is Zn that gets oxidized to Zn2 plus zinc solid into zinc ion solution. This is the oxidation half cell. So, this acts as a anode, and here the reaction is Cu2 plus aqueous reduced to Cu. Here it is a reduction. So, here it is a, this acts as a cathode, but of course, the two reactions will be taking place only when both of them are in connected. This will give the connection. If you have any bulb that is connected over here, then the bulb will start glow because of the flow of electrons. Here the electron flow from anode to cathode, electron flow from anode to cathode. So, if we keep an electric bulb between the two electrodes, then the bulb will start glow, or if you put any potentiometer, then there will be a deflection in the potentiometer from which we can read the EMF of the galvanic cell, and this only completes the external circuit of the cell. When it comes to the internal circuit, both the half cells internally are connected through another device called salt bridge. This is called salt bridge. The salt bridge is consists of, salt bridge is a U-shaped glass tube of which the two bends are dipped in the two half cells, and it is filled with agar-agar paste. The purpose of agar-agar paste is to allow the slow movement of electrolyte, and saturated solution of KCl or ammonium chloride or ammonium nitrate or potassium nitrate. Well, the purpose of the salt bridge we discuss a little later, but before that we complete the explanation for the working of the galvanic cell. So, here this is oxidation half cell where zinc rod is dipped in zinc sulphate solution. This is reduction half cell, copper rod dipped in copper sulphate solution. Now, zinc being more electropositive than copper, the preferential oxidation will be for the zinc. So, zinc undergoes oxidation to Zn2 plus, and the electrons will flow from the external circuit and go to the half cell of copper sulphate, where the cupric ions, here zinc from the metal rod, zinc from the metal rod goes into the solution. So, here concentration of Zn2 plus increases, weight of zinc rod decreases, because zinc is getting dissolved into the solution as Zn2 plus. So, Zn2 plus concentration in the solution increases. Weight of zinc, because the zinc is getting dissolved, the weight of zinc rod getting decreased. Now, the electron flow through the external circuit. As a result, the electrons that are coming from the anode, they go into the solution of the copper sulphate, where they will reduce cupric ions to copper metal. So, here cupric ions deposit as copper. Here zinc is getting oxidized and dissolved in the solution as zinc ions. So, zinc ion concentration is increasing. Here cupric ions from the solution getting deposited as copper in the metal rod. So, here what happens? Cu2 plus ion concentration in the solution decreases, weight of copper rod increases, and so overall reaction is that Zn plus Cu2 plus to Cu plus Zn2 plus. This is the overall reaction involved in this zinc copper couple. Zinc copper couple means a galvanic cell made up of zinc and copper, where zinc acts as oxidation of cell and copper acts as reduction of cell. And here the anode is negatively charged and cathode is positively charged, because when the zinc is getting dissolved as Zn2+, the positive charge will be in the solution and on the rod it is the electron that flows. So, the negative charge is on the rod. So, is the reason that the electrode is negatively charged. Here cathode is positively charged because cupric ions are getting deposited. Positive charge is getting deposited on the rod. Here positive charge is dissolved into the solution and here positive charge is depositing on the rod. So, rod here will become positive charge. The sign convention for anode and cathode here, if you look at it, this is exactly opposite to the sign conventions that what will give for electrodes anode and cathode in the electrolytic cell. In electrolytic cell we say anode is positively charged because cations are getting deposited. Where cations getting deposited, that should be negatively charged, where anions getting deposited, that should be of positively charged, according to what we learned in electrolytic cell. But here the convention is exactly opposite. So, here there should not be any confusion as far as the sign conventions of the electrodes is concerned. In a galvanic cell, anode is negative, cathode is positive. In electrolytic cell, where electrolysis takes place, there cathode is negative, anode is positive. So, exactly it becomes opposite. So, finally, here weight of zinc rod decreases, concentration of zinc sulphate, concentration of zinc ions in the solution increases. Here weight of copper rod increases and cupric ion concentration in solution decreases. Now, what is the purpose of this salt bridge? So, here a simultaneous oxidation and reduction. So, basically what all is taking place is simultaneous redox reaction. Simultaneous redox reaction is the principle involved in this whole galvanic cell. Because of the simultaneous redox reaction, there is an electron flow along the external circuit. Fine. When there is an electron flow along the external circuit, then also what happens here, as the zinc ions are getting accumulated over here and cupric ions are getting deposited. So, obviously what will happen is that here there will be an accumulation of positive charge over here and accumulation of negative charge over here. As the ion is entering into the solution and here electron is entering into the solution. So, there will be accumulation of positive and negative charges at the metal metal ion interface. This is on the other way when we have a cell where the electrodes are separated by a membrane, there we call it as a liquid junction potential. At the liquid junction potential, there is certain, the potential is developed because of the accumulation of the charges. Charges will get accumulated exactly at those places where the oxidation or reduction is taking place. So, this is a place where the oxidation and reduction being taking place. So, there will be an accumulation of charge. If once charge gets accumulated in any of the half cells, for example, like here if the excess positive charge is getting deposited at the metal metal ion interface, what happens is that because of the accumulation of the positive charge, further oxidation is prevented. Similarly, here because of the excess negative charge that is accumulated on the surface, that is otherwise what we call liquid junction potential. Because of the negative charge that is getting accumulated, further reduction is prevented, because as a charge gets accumulated, further process is not favorable. So, as a result what happens? Excess positive charge will be deposited at the anode, excess negative charge will be deposited at the cathode. So, this finally will stop the working of the galvanic cell. Because of the deposition of the the opposite charges in two of the half cells, the cell potential drops to 0, cell will stop working. If cell stops working, then there is no purpose of the galvanic cell at all. So, in order to prevent the accumulation of the charges in any of the half cells, we use another small device called salt bridge here. So, what salt bridge will do is, salt bridge will not allow the accumulation of the charges. Where we have the two half cells are separated by membrane, the other way what we say is the salt bridge will prevent the mixing of the two electrolytes. As a result, accumulation of the charge can be prevented. So, then what salt bridge will do and how it will prevent the accumulation of the charges? This positive charge whatever is accumulated, here we use the KCl solution, and here why we are taking KCl solution, that is another important point. The point is that, so the basic purpose of the salt bridge is to allow the free flow of the charges. The salt bridge will allow the free flow of charge from one half cell to the other half cell. The positive charge from here will get transferred into the cathode, negative charge from here will get transferred into the anode, or in other words, in simple words, opposite charges will flow in opposite directions. As a result, neither the positive charge accumulates in the anode nor negative charge accumulates at the cathode, and it will keep the cell keep working. So, the salt bridge allows the free flow of charge, free flow of charge. The purpose of the salt bridge is to free flow of charge. As a result, neither positive charge nor negative charge will accumulate in any of the half cell. So, cell will be keep working. Then how that it will allow the free flow of charge? Here we take an electrolyte like KCl. Why we take electrolyte like KCl? KCl is a very strong electrolyte, point number 1. It will dissociate completely to K plus and Cl minus. So, the potassium ions and the chloride ions, two oppositively charged ions, will be keep moving across the two half cells and will allow the charge to transfer from one half cell to the other half cell. But this salt bridge will not allow the transfer of ions from one half cell to the other half cell. It allows transfer of only the charge. It will allow the only charge will transfer from one half cell to the other half cell, so that both the solutions will be maintained neutral. Okay. If you take the salt like KCl, K plus and Cl minus, they both are having identical charge density, means K plus and Cl minus being isoelectronic, number of electrons are 19. So, 18, K potassium atomic number is 19, so K plus is 18, chloride atomic number is 17, so chloride is 18. So, K plus and Cl minus both having 18 electrons, having similar charge density. As a result, both of them will allow the same amount of charge to transfer from one half cell to the other half cell. If you use potassium and iodide, iodide being very large in size cannot carry the same charge density as potassium. Similarly, if you take Na plus and Cl minus, Na plus being small cannot take the same charge density, or if you use any dipositive or dinegative ion, then the charge carrying capacity will be less. So, we select the strong electrolyte, point number 1. Point number 2, the mobility of both the ions should be identical. Mobility of both the ions or charge carrying capacity of both the ions should be same. That is another very important condition. K plus and Cl minus being isoelectronic and are having the similar charges magnitude, similar magnitude. So, they both will carry the mobility of both the ions. What is the mobility? The velocity with which both of them will flow. The mobility of both the ions is same. The charge carrying capacity is same. So, equal charge can be flowed from one half cell to the other half cell. If you use any other ion with chloride, the charge that transfer in the opposite direction will be either more or less. So, keeping this in view, that only those electrolytes where the two opposite ions will carry the equal are having the equal charge density are only being selected, and they are KCl or ammonium chloride or ammonium nitrate or potassium nitrate. So, the charge will be. Then what is the purpose of agar-agar paste? The purpose of agar-agar paste is, first it is filled with agar-agar paste, and then the solution is allowed to flow, that is to give smooth and slow flow of electrolyte. Otherwise, if agar-agar paste is not there, what happens is solution will suddenly move from one side to the other side. There will be a sudden flow of solution. But if you have agar-agar paste in between filled in this, then there is a slow movement of the solution, and as a result charge will be transferred equally in opposite directions. So, this is the purpose of the salt bridge, and these are the reaction, and this is the overall reaction, and this is the sign convention, and this finally, because of the electron transfer from one half cell to the other half cell, there is a EMF that is generated. So, this completely gives us the construction of a galvanic cell using zinc and copper. Instead of zinc and copper, we can use any other, either we can use any other two metal combinations, metal non-metal, two non-metals, and also we are having several other different electrodes. That all we study under types of electrodes. Okay? So, now this is the construction and working of a galvanic cell using simple zinc copper couple.